Hey boys and girls, we're here at Boxabl in Las Vegas, and we're going to have a chance to have a look inside one of their units right here. Galliano is going to show us around, so and look I got poker chips, so it's a sure bet that that this is going to be a good video.
There you go.
Okay, let's have a look, and
All
you
right.
can tell me all about it.
Let's check it out. This is the Boxabl Casita. Step inside.
Great.
So yeah, welcome in. This is actually our first product that we're starting off as part of our building system. It's a little studio apartment. It's about 20 feet by 20 feet with 9.5 foot high ceilings. We have a whole ton of innovation here, more than meets the eye. And the idea behind the company is that our technology is going to enable mass production of housing, because right now most houses are not built in a factory. And of course, everything is much more higher quality, more reduced costs, more efficiency if you build it in a factory. So we have a bunch of innovations that's going to make that possible, and we'd love to give you a tour.
Absolutely. I'd like to see, but let's just go over here and have a look at a little bit here on how this looks. I mean, this has got all the creature comforts at home. And if you're a hunter, I like to hunt. I could definitely see me, having this as a hunting lodge. I mean, you even got a dishwasher.
There you go.
So, I mean, this is all what I think is high quality. And then when I look in here at this bathroom, so we got a washer dryer kind of combination.
That's right.
And then you look at the bathroom. Why don't you pop in there? I mean, look at the shower. I mean, this is big enough for anybody. This is
great.
not like
it's comfy
like
too.
economy.
If you want to try it out.
Yeah. maybe in a while. Not right now.
Yeah, we really tried really hard to not compromise on anything. We had to solve the shipping problem for houses. The reason houses are not built in a factory is they're just so big.
Yeah.
So we wanted to figure out how to ship these buildings highway legal at the lowest possible cost, but we didn't want to have a compromised room dimension. We didn't want to have low ceilings. We didn't want to have small appliances. Right. And we pretty much were able to achieve everything we wanted. And the resulting building is not only going to be lower cost than people can build using traditional methods, but much faster to build. They're also going to have higher ratings. So our buildings will have high wind ratings, snow load on them, massive energy efficiency. The list kind of goes on of the various metrics where the Boxabl buildings are outperforming the traditional methods. So of course we're here in Las Vegas, Nevada with our first factory. We've been in production now for just about a year. And as we walk around, you'll see that the way we're building these houses is very different than what you would see in any traditional methods for building houses. So we can start right over here and get a look at some of the materials that are actually in the walls. Of course, most houses are built with lumber frame, wood and nails. We've kind of scoured the whole world for different building materials, different manufacturing methods to meet all the various requirements that you need for a building, and we landed on these laminated panels. So essentially we've gone from a regular wall assembly that might have 1,000 nails in it, 100 little pieces of wood, down to these bigger parts. So what we do over here is we lay them out. So in this generation of the product, we have the steel skin. So for example, these are 4 foot by 10 foot sheets. So we'll lay out 5 of those sheets. Then we'll come over that with polyurethane adhesive. Then we'll lay out the EPS foam core, and then another layer, which is the interior wall board. And then around the perimeter of that panel, we'll put in these LVL and PVC extrusions. This is still the first gen. In the next gen, we're moving to basically fiber cement board, EPS fiber cement board. And another thing about this process is all these materials are cut and formed by computer-controlled cutting equipment so that they can all assemble together in a very precise, automated way.
Oh, this is machined.
Yeah, so this is actually cut with a hot wire. So we get the big blocks of foam in, and then we cut them down to the exact shapes that we need to give us things like holes for electricity, electric wires, and other things. So
is that cut or is it extruded? Those
the foam is a big foam block that's
wire.
actually cut by a hot wire. And there's other methods for cutting that too that we're exploring. This PVC is extruded, and
then cut.
Yeah, and then this is all kind of first generation stuff. We got in here from a single prototype that we built by hand and ran straight into this this production rate that we're at now. So we're now taking a step to go to the next generation of the product, all new manufacturing equipment. So over the next 6 months, we're going to be changing all that stuff up, and it's going to be much better. For example, right now we build one wall in about 20 minutes. And of course, that's way better than the speed it takes to build a traditional wall. But after we get this new equipment in, we think maybe like 2 to 3 minutes or something like that per wall.
Yeah, right here, you've got a huge opportunity. I would never do this in a production kind of atmosphere. I would never machine it because you can form this. I mean,
Yep.
And when you put it in a steam box, it's free almost.
Right.
And then you pop this in. In order to get these holes and whatnot in, just put in a pipe box and then blow the foam around, or actually let the foam expand around it, and you're all done. Actually, this and that could go into the same box, and now you're done in not 2 minutes. You're done in a few seconds.
Yeah.
That's one of the best ways to make.
Yeah.
One of the concepts we're exploring.
Yeah, you don't have to explore that too much. That's being done right now. So you might want to just jump straight into it.
So one of the next things we're going to do is our own foam molding plant, which, if it makes sense, will include a custom mold so that we can take the hot wire cutting out of the mix there.
Yeah.
And then this is EPS foam, styrofoam.
Yes.
We've looked at other stuff like polyurethane, and this makes the most sense for a number of reasons.
Well, it's the least expensive. If you go to EPP, you could get maybe some more strength out of it and stuff like that, but it's just more money.
Yeah.
You really don't need it.
Yeah.
This is fine.
Yeah, the weight, the strength, and the energy efficiency, those are the main things we're getting out
Thermal
of that.
conductivity too. This is good for keeping out the hot and the cold.
Yeah, so a traditional wall, you have lots of lumber studs that are leaking energy, and we don't have that. This is going to be uninterrupted EPS foam through the whole.
So what are you using to glue it together?
So that's this line up here. So this is the vacuum lamination system. That first little thing with the red and black lines, that's where the polyurethane, water activated polyurethane is extruded out. So that rides over the top of the panel as the layers go down. And then it gets pushed further in to that far side of the machine, which is actually a vacuum lamination. So it pulls the air out, and then the atmospheric pressure pushes down the weight on top.
So it's kind of like a Verum process. Like
Sorry?
Verum, if it's a Verum process, a vacuum system, they kind of use that for like exotic, like airplanes, like carbon fiber airplanes and whatnot.
Yeah, there's a few pros and cons to this method, and we're actually switching in our next gen to just like a flat mechanical press.
Yeah.
Number of reasons why we like that. And then the adhesive extruders will be pretty much the same in the next gen. And then actually, this universal panel with no steel, just fiber cement board, is going to then get fed into a cutter that's going to cut it down to the smaller panel sizes later on for that next gen.
Well, let's go down and have a peek.
Yeah, we'll just go this way a little bit. You can see some of this. So, we've got a few, CNC cutters over here. So one piece that you didn't see there was the internal surface of the wall, which is type magnesium oxide board. It's going to be fiber cement board, similar product, but we're cutting that over there just with a regular CNC. And then here we're cutting these LVL lumber pieces to shape, and then we're gluing that PVC to that LVL over down there. And we've also, for that next gen, we've been able to cut out, right now all of that lumber has that PVC laminated to it. In the next gen, a lot of it is just lumber only with no PVC in it. So we were able to cut out a bunch of material on that because we realized we only needed it for certain reasons.
Yeah.
Yeah, so the material flow is this is the inside wall material, and the lumber, it's all kitted up per wall panel, right? Every card is one panel, and it all makes it to the lamination, and then from there it flows that way.
Yeah. How soon do you want to have up and running at the maximum speed that you want to get it going?
We're ready to improve what we're doing here ASAP. Over the next 6 months, that new equipment comes in and some things change, like the assembly line of the actual parts into the final house will double in size, so that the jobs being done at those stations will change a little bit. But yeah, so here you can see how it kind of goes together. This is just a sheet of steel to give us some more tension in the strength when we're doing bending the panel. But aside from that, it's just it's got foam, LVL around the perimeter, and they're actually pre-building it here, and then they're going to take it apart and build it again there on that next station, just because at this level we're trying to make sure everything's really perfect.
Huh. I never try and build anything 2 times.
Trust me, I know.
Yeah.
Primarily it's because of some of the capability on the panels, where we had some issues, some things were mixed while we were refining the proper process on the manufacturing side. Before we were cutting lengths by hand, the lengths of the material. Now we have a CNC machine, so it's inefficiencies basically that we still have in the process.
And the big thing is the glue is water activated, so it's kind of on a timer. So you have 20 minutes to assemble this thing, or you got to scrap the whole thing. Yeah. So we wanted to avoid that happening. And then, like I said, once we move into this next set of equipment, that's all gone. It'll all be fully automated, the panel production. Yeah, so this universal panel thing that we're doing, basically right now, there's different panels on the building. There's a floor, there's a wall, there's a front wall, a side wall. They're all a little bit different shape. And since we're building them all individually now, the components that go into those are then all different. What we figured out next is one single panel that gets built and laminated and then is cut to size later on. Right. So that dramatically reduces the components that goes into these panels beforehand. And it allows for easier customization later on. Different windows, doors can be just all cut as an afterthought. So this is a magnesium oxide board. We're switching to fiber cement board on both sides for the next gen.
Yeah.
But this is nice, it's good stuff too.
So is this paintable, or is this?
Yeah.
That's it.
Yeah, it's going to get painted in this next step right over here.
Got it.
So in the future, these panels, they're going to be coming off the mechanical press, then they're going to be moved in a overhead conveying system, and then go through paint line. It's very easy to paint a flat surface, right?
Yeah.
And
actually, you've got, this is your paint booth here.
Yeah, this is the booth where we're sanding.
Oh, you've got an open booth.
This is a sanding booth with some airflow. And that's where they mud it and they sand it, and then it goes to painting. So this is obviously something we're constantly looking at. Ideally, we wouldn't have to do this at all and come up with some sort of cover or so, but this is currently
one of the
process.
things that people are doing now is skinning. There's a lot of different wrapping materials that are available that, give you a fabulous finish, and if somebody wants to change the colors or something like that, well, they can, but it's going to be on their nickel, and a little tougher to do that. But if you paint them, what color are they painted?
So we were looking at different stuff, like wallpaper type stuff to put on. Didn't find anything where the numbers really crunched, and decided paint was the way to go. Just paint it white. We're part of those upgrades I was talking about is a whole new paint system where it's just a tunnel and it goes through the tunnel automatically. The real issue is the seams between the boards that, you know, you may or may not want to get rid of. You know, when you have to go in there with, you know, like mud, like in traditional sheetrock mud, that's where you get this kind of like finessing that needs to be done by hand. So we're considering just even leaving those seams in there as like a style feature. And I think that might be okay.
Yeah, that's when I was thinking that when I saw the guy sanding in here. Why bother? I mean, really, at the end of the day, people are looking at, you know, they know they're getting something that's going to be inexpensive. So why waste time on sealing them up?
You know, on the walls, they're going to be vertical seams 4 feet apart. We were thinking we could machine them into a little, you know, strategically 1/4 inch recess or something, and it might look totally fine. But we'll see. And you know, but this is what we're going for now. Just this. This is just one of the walls. That's the door opening, window opening.
Holy mackerel! This stuff's kind of expensive. Most people don't even want to touch it. It's might be something to put on your list of maybe knocking the price down.
Yeah, I mean, we only used LVL in general because we needed like dimensional accuracy.
Stability, yeah.
Common lumber is always a little bit warped, and that's not good for a product like this.
Also here, all the electric goes in, so all the wires go through the chases, so they pre-configure all that.
Perfect. Yeah.
You see here we have connectors everywhere, so when the roof goes on top, they just connect it together basically.
Plug and play.
Right.
Great. I love that. Yeah, that's a great idea.
Today we have 11 stations, and as you see, we have some sitting on blocks and then casters. Then we have a little lift to move station by station. So all this, we're gonna double in the first take on it. We double the number of stations, and it's gonna be a chain conveying system. The things are gonna sit on skis, leveling. This is an issue today. Always the leveling, you have walls on it and you move it, you pick it up. It's too much stress on the unit. It's got to sit on the same pallet or carrier through the entire process. That's going to be huge improvement in the next step. Yeah, it basically is station by station. You put one piece off the floor. This is where Paolo was talking earlier. That's 1/3 of the space. And the next floor that you see over there, that's another 2/3. So when that unfolds, it triples the entire space. But everything, utilities, appliances, the kitchen, the bathroom, everything is installed in that section there.
Yeah.
Which is going to be good, you know, when you talk about automation and all that in future.
So that joining section there, is that how you kind of connect the two buildings together, or the two halves together?
That's the hinge to fold the wall down. You're going to see it over there.
So we have an I-beam through the middle of the floor and the middle of the ceiling. And I think the main reason for that was to reduce the requirements of the panel, so that instead of having to be strong enough to span 20 feet, they would only have to span 10 and rest on the I-beam. And then the reason it's like that is because it hinges, the actual I-beam hinges.
I see.
You also see the gaskets here and the shape to stop water infiltration.
Those are fork tubes, because we pick it up from there.
Forklift trucks, So what's the preparation then at the job site? Is it have a foundation, or is it a slab, or what are you using?
It's going to be compatible with any foundation or no foundation, just depending on the use case. And then you want to have utilities ready to connect. That can be solar, it can be the grid, whatever. We're just kind of getting all the heavy lifting done to shortcut the process for the builder developer, so that hopefully their build time goes from 6 months down to 1 week or a month or something like that.
So this is really going to be like the automotive assembly concept we have to develop, right? We have one is making as many wall panels universal as possible, and then breaking down the tasks, you know, of this operation. Because for right now, there's a lot of things happen in this station. They put 3 walls and they do the plumbing, you know, for the shower. They start the bathroom cabinets and all that. And we currently, you know, our target is 4 hours. You know, you see we are over 4 hours now. If we achieve 4 hours, we get more than 2 hours a day. But we're you know, obviously have a lot of details to iron out here with standard work and different operations.
So are we looking at the bathroom and the kitchen then, or is that what I'm?
Yeah, exactly. And this is kind of what we call the core of the unit, where everything is.
Yeah.
That's the part that doesn't get folded up or compressed. And another cool thing is, if you think about a traditional house, you're going in through the door. So even in a factory, you know, you're going in through a door to install stuff. For us, you know, this remains open until we're done with it, and then we add the rest on. So this is easier to access in and out, whether it's a person or a robot arm.
Yeah.
These go through, we do dielectric testing, you know, make sure electric and all that is working, wrap a couple things. But this one is in the final stages. We can walk in there.
So do you ship these things? I don't see a stove in it right now, but do you ship it with?
Actually, that's how they get wrapped. That's a fully packed unit.
Yeah.
It gets this shrink on it,
Yeah.
and then that's how we, exactly how it gets shipped.
Yeah, but we get all the appliances in. We're able to fit them all into the fixed core of the unit. In the future, we'll probably be able to get furniture in. We're designing our own furniture. That'll all pack and fold up.
So you asked, that's how we cover some of the piping, right?
Yeah. But it looks symmetrical, so it looks good.
Don't like that though. We'll figure something out better for that one.
That gets like a little mask covering on it. Then you can see the hinges where the walls fold in and out.
Yeah.
And you can look in there if you.
It looks crowded. I'm good. I just I wanted to see that actually right there. So when this folds up, okay. So when the homeowner gets it, do they paint the hinges, or do they leave them open, or
the hinges actually take off? We take them off.
Oh, you take them off.
Yep. There's no need for them. Only when you move it again, you put them back.
Yeah.
And we've got some ways to make those go away in the next generation as well.
Like
some
those
built-in hinges inside the wall, double hinges and stuff.
Hey everybody, thanks for watching. The guys in Boxabl just gave me the tour of the century for the next generation of housing. I'd like to thank Christian and Galliano here for giving me a wonderful tour, and hopefully we'll see each other again. Keep watching. Thanks a lot. We'll see you. Bye.